Okay, guys, so I'm going to do this problem. Okay, so we need a calculator for it. And the region R, let R be the region enclosed by the graph of f of x, which is this, and the horizontal line y equals 4, as shown in the figure above. So this is f, this is y equals 4. We're going to need to know these intersection points. First, find the volume of the solid generated when R is rotated about the horizontal line y equals -2. Okay, so off to the side, I don't really have enough room. You don't have to show the reflection and then the washer itself, but I'm gonna just show you, I like to do this to help visualize it better. Okay, so let's just say, all right, let me just say the region R is like that. Okay, it's right here. And then, I know that doesn't look great, but then I'm going to take this y equals -2, and I'm going to rotate this around y equals -2. So when I do that, like, you know, this region is kind of going to get, I know it's difficult, like reflected. I could say like that, and then like this point. This is hard. I really don't know. It's not going to be like perfect. All right, so just to get an idea. So this is the center of the rotation. All right, there is space between the center of rotation and the region we're rotating, so this is going to be a washer and not a disc. So the inner radius, which is going to be empty space, goes from there to there, and then the outer radius is this longer one. So the inner radius is going to be like that, and then the outer radius, and then the outer radius is, or not the outer radius, but like the solid part of the washer, you know, is there. Okay, so that's what that looks like. So you can kind of see better that for this inner radius, I need to do top minus bottom. So that's going to be, let me do the outer one first. For the big radius, I have to say big radius, top minus bottom is going to be 4 minus -2. And then for the small radius, top minus bottom is going to be f of x minus -2. Okay, so here we go with part A. So volume equals the integral from this x value to this x value. So from the start of the region to the end of the region. So x equals, and now this I'm pretty sure is 0, 4. And it actually is, I checked it on the calculator. And then this one, I know the y coordinate is 4, but I gotta find the x coordinate. So, and guys, these are guide videos, so you wanna pause and try as much on your own as you can. Excuse me. So I graph it. Excuse me, I've got to find that. Second, I need intersect. Oh yeah, and this one there, I hit enter 3 times. If you see something like this, guys, like -1, like all that, this means times 10 to the -5th. This is 0.0, this is -0.000000, yeah. So this is essentially 0. I don't know why the calculator doesn't just give you 0. So 0, 4 is that one right there. And then this one, I just gotta move closer to it, is 2.34. So I don't even need to store anything. 2.34. So volume is going to be the integral from x equals 0 to 2.3. And then in here, I need the area of each cross section. And these cross sections are all washers. And since the washers are being stacked, like, you can think of them being stacked vertically. Wait. No, since the washers are being like cut vertically, like if you cut vertical cross sections, that's how you see the washers. That's why everything is in terms of x. Okay, so yeah, vertical, top minus bottom in terms of x. Horizontal, right minus left in terms of y. So the area with respect to x, so the area of a washer is pi, and then here you have big R squared. So the big R is top minus bottom here. So 4 minus negative 2 is 4 plus 2 squared. Minus, for the small radius, top minus bottom is f of x minus negative 2, so plus 2. And then you square that. Okay. So this is equal to the integral from 0 to 2.3 pi, and then that's 6 squared, so that's 36 minus, I know you don't even need to show like everything I'm showing, but you could plug it in right from here, I think. So it's going to be this with plus 2, and it's going to be squared. So it's x to the 4th minus 2.3 x to the 3rd plus 6, and then you're squaring that dx. Okay, so I'm going to plug that in. Okay, and go ahead of me, guys. You want to do as much on your own as you can. So 0 to 2.3 pi 36 minus x to the 4th minus 2.3 plus 6 squared. And then I close those. Okay, 98.868. All right, that's for part A. Part B. Region R is the base of a solid. For this region, or for this solid, each cross-section perpendicular to the x-axis is an isosceles right triangle with a leg in R. Find the volume of the solid. So what this means, guys, when they say with a leg in R, they mean that this, so we're going to be using top minus bottom. This is a leg of the isosceles triangle. It's a right isosceles triangle. So there's the right angle. And then the base and the height are the same. And these are coming up like out of the paper, and there's infinitely many of them. So I'm going to do the same thing. So volume is equal to the integral from 0 to 2.3, and then you take the areas and you add them up. This time, the area of an isosceles right triangle where the base is a leg is 1/2 base times height. But guys, the base and the height are the same, so it's just going to be like the base squared, and you're going to do top minus bottom for that. So top minus bottom here is 4 minus f of x. Top minus bottom. And then this is the integral from 0 to 2.3. And then this is 1/2. And it's 4 minus this. 4 minus this. So the 4s are actually going to cancel, guys. So I'm going to end up getting, and you can go a lot slower than me if you don't see that, plus 2.3x to the 3rd. So I'm subtracting all of these terms from 4. And that's how I'm getting this. And then I square it. And then dx. Okay. Oh, whoops. So math 9, from 0 to 2.3. And then all right, from 0 to 2.3, and then 1/2 negative x to the 4th plus 2.3 x to the 3rd, close parentheses, square it, dx. 3.574. 3.574. Okay. Now the very last one. The vertical line, x equals k, divides R into two regions with equal areas. Write but do not solve an equation involving integral expressions whose solution gives the value of k. So, guys, you've got to imagine, okay, so we want to find like a vertical line where it looks like the area to the left and the right of it are equal. I don't know. Possibly there, possibly. So I'll just draw a line like this. X equals k. Guys, so this area from 0 to k needs to be equal to the area from k to 2.3. You've just got to express that using integrals, and then you've got it. So we don't actually have to solve for k. So the integral from 0 to k of, let me see, let me look real quick at how they did it. Oh yeah, they just used f. They didn't write the whole function. So top minus bottom, 4 minus f of x. Yeah, because the area would be top minus bottom dx equals the integral from k to 2.3, 4 minus f of x dx. And that's it. That's all you have to do for that one.